conditional statement is always going to be in a form of if then. If something, then something else. If you do your homework, then you don't have to worry about being on the deficiency list. Okay. Now, if it is morning, then the sun sets and the sun is in the east. Is this true? Yeah. Okay. Now, the thing is here, the hypothesis, there's always two parts to this stuff. There's the hypothesis and there's the conclusion. Now, the hypothesis is used for the idea of what are we looking for? What could be possible? Okay? The conclusion is exactly what that is. It's a conclusion. It's a result. It's what happens if. So, let's take a look at this. I want to identify the hypothesis and the conclusion of each conditional statement. Now, when we're taking a look at this in terms of an equation, if something happens, then we get something else. So if I have the equation, okay, then x is equal to 2. Whatever follows the if, so this right in here, that's going to be the hypothesis. Whatever is over here is going to be the conclusion. Okay. If this, then that. That's all it is. Makes sense? Okay. Let's try this one. What's the hypothesis and the conclusion? Well, what's after the if? Okay, so we've got a plant is growing, so that's our hypothesis. It needs water. Is that the conclusion? There you go. So if you're going to grow a plant, you need water, right? No, hypothesis and condition. This is just an example. Just an example. Just like this was an example. Okay. Now, this is an important idea. Some conditional statements are true and some are false. This is called the truth value of a conditional statement. A statement is only false when the hypothesis is true and the conclusion is false. Okay? If a rectangle has a width of 5 and a height of 4, then the area is 30 square feet. Is this true? No. How do we calculate length and width? To find the area. We multiply them, right? So if I go and multiply that together, what's 5 times 4? 20. So is this statement true? No. But you can only proceed from a true statement. You cannot proceed from a false statement because you can't conclude anything from a false statement. Okay. So, is this true or false? If an angle is obtuse, it measures 120 degrees. Is this true? But what is this saying? Correct. If an angle is obtuse, it measures 120 degrees. So anything that goes and lists it as an obtuse angle must be 120 degrees. Well, that is clearly false, correct? So if it's false, explain your reasoning. Well, it's false because not all obtuse angles are 120 degrees. Easy enough thought, right? Try this one. If two parallel lines intersect, then they form acute angles. You're right, parallel lines don't intersect, so I can't say anything, right? Because if two parallel lines intersect, this idea right here, that is definitely false, correct? Because that is false, I can't go and conclude anything. Because how could they intersect and form acute angles when parallel lines don't intersect? Doesn't make any sense, does it? Well, yeah, but then those lines wouldn't be parallel to each other. So, now, converse. We're not talking basketball shoes here. The converse of a statement is a statement that is formed by exchanging the hypothesis and conclusion. So, the converse of a statement, if P then Q, has the form if Q then P. This idea is important because when we go through and identify our statements, we use this to help you out. So, when we have our regular old if-then statement, okay, that would be is, right? Or this right here. So if P then Q, the converse is going to be if Q then P. So that's something you definitely want to have in your little books, don't you? Because that way you know what it means when it says the converse of something. So, remember when we said, if it is morning, then the sun is in the east. We said that was true, right? Does it make sense if I say, if the sun is in the east, it's morning? So if I asked, say that again? Yeah, it's always the same. So, if it's morning, do I know where the sun is going to be? Yeah. And if I know where the sun is, can I tell what time of the day it is? Okay. So, this works. If it is morning, then the sun is in the east. If the sun is in the east, then it is morning. Now, the converse doesn't always work. Okay? Let's try this one. If an animal is a duck, then it can fly. Is this true? Well, we don't look for little things like that. When we're talking about a duck, well, a duck is a duck is a duck. We're not going to sit there and take a look at it and run, well, what happens if it's this? What happens if it's that? We don't do that. A duck is a duck is a duck. Okay? And ducks can fly. So, if an animal is a duck, then it can fly. Now, the converse of that, if an animal can fly, then it's a duck. Is this true? That's false because there are other animals that can fly. Okay? Now, these are the things that you got to kind of keep in mind for yourself is when you're talking about converse. Does it spin around? Now, there's also something else that I want to point out to you here as well. When I take a look at this, it says if an animal is a duck. Well, we're talking about an animal and an object, we need a little bit of a qualifier. This is going to be the hypothesis. This is the conclusion. Is a duck, it can fly. Because we wouldn't want to say a car is a duck, right? And then can fly down here, it is a duck. So be careful about that. If I need that, if an animal, if something, if I need to have that qualifier in there, that's not part of the hypothesis, okay? So, continuing on. If an animal is a dog, then it has 4 legs. Is this true? Okay. Now, if I want to go and identify what's the hypothesis, well, in this case, is a dog, that's the hypothesis, and we'll use that as P. Yes, sir. It's not so much the idea of dealing with sentences. In mathematics, we have a specific language, and we have this idea of logic. If this, then that. And we must make sure that you understand how to form these ideas, how to state things, so that when we are doing something, we know exactly what it's going to be. You know, that's like the person that says, can I go to the bathroom? Well, the question that they really want to ask is, may I leave the room and go to the bathroom? But that's not the question that you ask, is it? Can I go to the bathroom? Well, yeah, I suspect that you probably can. But that doesn't mean that I'm going to allow you to leave the room to go and do it. Okay? So just like we have to be careful about how we construct our sentences, and you got to keep this idea in mind that words have meanings. Okay? So when I get to this here, and we're having statements like this, granted, these are simplistic right now. But when we start talking about more complicated things, you have to have the structure down of if something, then something, and understand that, yes, this is true. No, this is false. If we have if 2 plus 2, then it is, yeah. If we are adding 2 plus 2, then the result is 4. Yeah. And that's logic. That's the equation. That's the understanding. You already have seen how that works. Now what you're doing is taking a look at the understanding that goes underneath it. Okay? That the statement 2 plus 2 equals 4 is always true. Because math is always based upon true statements. We can't get somewhere if we have a false statement, unless we need it to be false because the condition says that. And we'll get to all those other things. You just need to understand the logic at this time. So, it has 4 legs. Converse, we call that Q. So now, we said it's if P, then Q. Yes. Yeah. No, and we use P to represent some statement. We don't know what it is. We use Q to represent some statement, whatever it is. So if P, then Q. Now, if I want the converse, that becomes if Q, then P. Okay? So for this one, it would be if an animal has 4 legs, then it is a dog. Is this true? Whenever we're looking for something to be true or false, it is always or never. So, Is there a situation that you could have an animal that has 4 legs that's not a dog? Yes, so this statement is false. It is not true. And this comes back to it because if you get an answer to something, it has to be able to be applied back to its original thing. So let me ask you this. What is the square root of 4? What number squared is equal to 4? Negative 2. Yeah, if I take 2 squared, I get 4. If I take negative 2 squared, I get 4. But now why is it that when I take the square root of 4, I only get 2? Because there's another set of constrictions upon that in the way it works. So we need to have an understanding of this. Just because I go and take the square root of something to find a number doesn't mean I can take that number and have all the possible numbers to get back to where I started from. One of the things that we end up playing with a little bit more when you go through algebra is something squared and the square root of a number are related, but they are not exactly the same thing. So it's good to be able to take a look at it and read it. Okay, so if x is 4, then 3x plus 7 is equal to 19. Is this true? Well, if I put 4 in for x, 3 times 4 is 12. 12 plus 7 is 19. Okay, so that is true. So here's our p. Here's the q. And if I do this, if 3x plus 7 is equal to 19, then x is equal to 4. Is this true? This is an example of the necessity of this idea. If you get an equation, do you know how to go and solve it? You know that you can take 3x plus 7 equal to 19, subtract 7, 3x is going to be equal to 12, divide by 3, and you get x is equal to 4. Now, if my procedures were not correct, if I wasn't allowed to do all of those things, I wouldn't get a 4. I'd get something else. If I did this problem incorrectly, and I got that, I didn't get the correct answer, did I? These are two equivalent statements. They mean the exact same thing. Why? X is equal to 4. Simplified, or just what it is. But we need this ability to go and switch them around. So if x is 4, then this is true. If this is true, then x is 4. We need that ability to go through and do that. So, let's try this one. Write the converse of each conditional statement. Use the Venn diagram to determine if the converse is true. If an insect is a mosquito, then it can fly. So, if we take a look at it, what is our hypothesis? What's P? Well, it's a mosquito, right? Then the next one is going to be what? Can fly. So, if this is going to be our P, and this here is our Q, and I switch it around. So that means if an insect can fly, it, or I should say, put the then in there. Then it is, my brain is running too fast today. Is this true? Is this true? The answer is no. So it is false. So the other thing is, you didn't answer the question. You were correct in your assumption as to what it is, but you didn't answer the question. The question was, is this true? And you said false. Well, it is false, but is that the answer to the question? No. See, this is where you have to learn how to read, listen, and understand what's being asked of you. So, what about the next one? It says if a mosquito bites, then it's a female. If I switch that around, if a mosquito is a female, then it bites. Is this true? Yes, because all female mosquitoes bite, correct? They're the only ones that do. Yes. So, what I want you to do is I'm going to give you about 90 seconds, and I want you to go through and identify the hypothesis and the conclusion in each one of these. Read the instructions. All right. So, let's see. Hold on. What's this at? Ooh, Mason. So, for A, what is the hypothesis? Okay, good. So this is the hypothesis here. So, then what is the conclusion? Okay, so then that follows. Okay? That works, right? So let's move on to Gavin. So, in this case, Gavin, what is the hypothesis? Golden delicious apple. Okay? And the conclusion is yellow color. See the front chart up here? Yeah, that's how it correlates. It's okay. Let's see, Logan. So now, what is the conclusion and the hypothesis here? Okay. Would it be the 2 points? Or would it just be the collinear? You know, this goes back to like if an insect if an animal, okay? 2 points. If we're talking about 2 points, there are a lot of things that can be with 2 points. So they're qualifying what is collinear. If 2 points are collinear, so we'll just be leaving it at collinear. So then the conclusion would be what? Coplanar. So This is saying that if 2 points are on the same line, then they are also on the same plane. Is this true or false? Still your question. You sure? Why do you say false? Because I questioned true? Bad idea. Yeah, but could I put that line on a plane? True. If 2 points are collinear, then they are also coplanar. Because how many points do you need to make a line? 2. So, I'm going to give you another 90 seconds here, and I want you to do these. Jacob, what is the converse of number 1? Or of D here, I should say. Good. You're right. Is that true or false? Which one do you want? You want true or false? True. Good. So, if I have either one of these two, then x squared is going to be equal to 9. This is correct. So, let's see. Hey. So, what is the converse for E? Is this true? This is false. So you mean Thanksgiving is going to be in 2 days? It's a Thursday. See, that's the catch. Yeah, Thanksgiving is going to be on a Thursday. This is true. But it's not every Thursday's Thanksgiving. So, let's take a look at the last one here. So that puts us at Hannah. So, what is this one? like that. Is this true? Is this true? And you are exactly correct. So, all right, there you go, and I'll let you guys get to the assignment.